I've been thinking about Halloween coming up, and I usually like making some automated mechanical thing that jumps out or something and scares people. It's fun. It's a mechanical funness. I can't explain it. Anyway, I was going to make a project today, but then I got thinking, there's so many projects, which one do I make? And then I got thinking about the different ways that you could power, like robots or spiders that jump out, things that come down, things that pop up, things that make noise, you know. What systems do you use to put this together? There's servos, there's stepper motors, there's pneumatics, there's motors. So anyway, what I thought is we would test some of the different ways and talk about them, and maybe it'll give us an idea to build something, but that's not really the idea of the video. The idea of the video is to show you the methods that you can make something move. Can. Let's get started. It's a blinker. Oh, this one works too. This has a little gear on it, that might be useful. I think that's a servo. Is that a servo? I was checking out this motor and it says DV 5.9. So is that DC 5.9 volts? Probably. But I like this. It has a little pulley, like a V groove type thing. I might be able to run a string through that. Maybe. I'm mixing battery types. Now we got 6 volts. Alright, that ought to light her up, huh? That's way too fast, though. I think this is a 1.5 volt motor. Stepper motor. Look at this thing. 21.6 volts DC. Wonder what the ratio is on that. This could be very promising. So this motor likes to run at 20 volts or so. Let's just see what a real small voltage would do. It still turns. This is a 18650, so it's what, 3.2 volts. Not that much torque. That's 6.4. Kind of like this little setup that I found. I have no idea what the gear reduction is. But if I can make a new pulley for this, 3.25. Okay, so I'm in SolidWorks. Make a new one. Part. I want to sketch a circle on the front plane. And I want to create another sketch. This will be the outside. We'll go an inch. Remember, this one's 0.325. Okay. And we can extrude. Features. Extrude. It's coming out. How thick do I want it? Let's make it ½ inch. Yeah, ½ inch sounds good. There we go. Okay. Now we have a simple ring that will fit on our gear, our shaft. Yes, there it is. So let's get the lid open on it. Let's get a more reasonable color, shall we? There we go. There's white. So now I have to turn on the auxiliary. That'll turn on this camera so I can watch it progress. And then the printer button should, kick down the panel. And I remember this fan. See this fan? I need to replace that. It's not starting on its own. That's not good. If that fan stops, the head of this thing will actually melt itself. It really needs that fan. It's important. Here's the glass building plate. Need to treat that with glue. And the filament that's loaded up is this white stuff, ABS. So I'll set it up for ABS and print it in that white, since that's what's loaded. Preheat. ABS. Get the bed going here. This one's the bed. We're at 23, going to 100. So that's why you need to preheat, because this whole bed has a heating jacket underneath it, elements. And it makes things stick to the bed by heating the bed first. The next step is to prepare the surface that the printer will be printing on, and it's a piece of glass. I wish I had a thicker piece, but this is all I have right now. It'll be fine. And this is just Elmer's school glue. It's like purple. And this just helps the print stick. And I've noticed that if you put this school glue on, you should let it dry thoroughly before you put it on the heat. Okay, there's the two I want to print. I just have to make sure I'm printing in ABS. ABS should be 230C for the printing, and the bed should be, I've got it set for 80C. I've got the G code on the card, so I'm going to put that back in there. I've got the glass in there, ready to go, and it will home itself before it continues, so it's not a big deal that I move that. I think I managed to get the print started. You can see a little bit of circles on there when it started. So it was a little challenging getting it going again, but once I got into it, I remember certain things. It's like riding a bike. This is on my phone, but you can see the machine running from another room on the phone. This is how I do the time lapses for the video. This computer's snapping a shot every 15 seconds with this camera here looking that way. %. Looks like it's starting the top taper, so it must be getting near done. Let's go look at it. Yeah, I guess it's got a ways yet. Well, the print is done, and I think it looks kind of weird. I don't know, it's just, I'm not sure, that looks kind of rough on the sides to me. But we'll pull it out of there when this cools down a little bit. It just finished. Yeah, we got some roundness problems, that's for sure. See these bumps in here though? It's not layering properly at all. That should be smooth. I've decided to run the job again using the same settings, just to rule out this reel of plastic getting stuck, because it is getting down to the end and it could have gotten stuck in there. I pulled it out, but I'm not sure that's what it was, but we'll soon find out because I'm printing the exact same settings. So these prints came out a lot better. I'm gonna zip that off right there. I don't need this piece. I'll leave this one though. Pretty smooth. It just doesn't have the pop, you know? I mean, this is something that you would see on a child's mobile. It's just not scary. And the reason why it's not scary, it's not fast enough. I mean, this is a pretty cool experiment, but for Halloween it just ain't gonna cut it. Because if I gear that motor so the string goes faster, it's gonna slip. You can always fix a problem, but are you chasing a problem, or should you just use the right thing in the first place? So I have the right thing in that box over there. Let's go over and look at it. So you push air in the top, pushes the piston down. You put air in the bottom, it pushes this piston up. Yeah, let's play with this a little bit. We need air. So yes, I throw this stuff in a box every year after Halloween and I reuse it. I bought this kit one time and I've just been playing with it ever since. Actually, it was a pretty good value and it's easy to hook up. You just push these in. You don't have to use any tools. I did when I first set it up, I think, but after that you just use these snap connectors. And depending on where you put these in the order you put them is how the cylinder will push it. You know? The only thing we really need to make it run right now is air. And my fitting's over here for that. Can you see a damn thing? I'm telling you. Pay attention. Sorry. Yeah, let's put some air on here. See how that's coming up real slow? There's a button on here, I can trigger it. It's red, the red button. But this is the AC one, and I can hook this up to AC mains and control it that way as well. And that's how you use a controller board. It has a relay in it, and it sends 110 volts to this when you want to activate something. Now the way it's coming out slow right now, you can adjust all that with this manifold. See any faster down? Not really. It's this one. No, I don't know what I'm doing. Oh, there we go. There we go. That's what I was expecting. And then you tighten it up. Can you see these controls? So I turn this one to adjust it. There's the fire button. And then you tighten this screw up on it when you get it adjusted with this. It's like a bleed for the air. I think that's okay. Except I want it the other way around. I want the cylinder in when it's relaxed, in its relaxed state with no power applied to the coil. So we can just switch the air lines around, take the air off. So you push these blue things in, then you pull out on the hose. I'll put this one in the top one, this one in the bottom. That should reverse our relaxed state, I call it. I made that up. Okay, now it's in, see? That's what we want. So just by playing with the order on this manifold and using the air bleeds, the mufflers, and an electronic switch, you can have a lot of fun with this little cylinder. Right now I think it's running about 30 pounds, and I have this little compressor. I think I started with about 60 pounds, so I'll press it and you can watch it go down. That's not bad. Tank might get you 25 or 30 of them, good ones, before it starts petering out, you know. So it's pretty good on air, really. And then you don't need the compressor running, because that's annoying as hell. So yeah, you could connect your spider right to that and shoot it out of the wall and blacken somebody's eye. Servos. You guys know what servos are. Everybody's seen servos move. I was going to hook up a demonstration on the Arduino, and I thought, no, I don't really have time for that. So I thought I'd just skip it, because I know you've seen servos, but I did want to talk about them just a moment in this type of application. Servos can be a really good thing for animatronics, moving limbs. As long as you don't have to move something more than 180 degrees, that's where the limitation of these are. Yes, you can get 360 degree servos, but then there's limit travel problems. And you might as well, at that point, just go up to a stepper motor, which can run at any speed and stop on a dime. That's an Arduino stacked with another board that controls the servos on this 3D printer, and they're widely available. I don't think they cost that much either. Once you get the Arduino, you'd have to wire it and program it yourself, but you can see how many wires are on this crazy thing. The point I wanted to make about this is a servo driver, and it can run, servos that size. This machine has 1, 2, 3, 4 of them. So it's got one on the motor for the print head. It's got one on this side to lift this side. One there. And then one there in the back that moves the bed back and forth. So that's 4. And I'm sure they make others that will even drive more motors. But man, if you had some servos and one of those programming boards and some time on your hands and a desire to make animatronics, you could make a really cool thing. It's fun exploring what you can do during Halloween and get people scared. Here's an old book from 2016 that came with the Pneumatic equipment when I bought it. And they have these attachments, and you just add your own cylinder. And I was looking at this for ideas. There's the attacking pop-up mechanism. That's classic. Door slammer. And you don't have to drill your door. That'd be nice. Regular pop-up, so this one's just a single. This looks like a double. And then they got a spider drop. Yeah, but I was thinking it over, and I thought everybody has these pop-up things, and I think the pneumatic cylinder could help us with sound effects. And I think it's frightening if you're walking through something and you hear a loud bang, that'll get you to jump, and then you can follow it with something else. But just natural loud bangs are better than a stereo any old day, playing the same old haunted house sounds. So I thought if you could put a pneumatic cylinder on a couple pieces of wood and just have them banging together, it'll sound like a door or something. You could even hang chains from it. Let's do a little mock-up and see how hard that would be. Making these two pieces of wood slap together with a hinge. That'll allow that to swing open and shut with a slap. And then I just have to attach this. I'll have to move this bracket down to here. Oh look, they have a swing. They have a pivot point. So we could come up with the pivot, attach this bracket to the piston, and then attach it to this wood. I'm just freestyling it. Freestyle. Stay with me. Stay with me. Let me know if I'm doing it wrong. Don't worry, nobody got hurt. Let's do that again. That's annoying. Might just have to round this off with the grinder. Okay, so we're going to drill this to this. That's a nicer fit. this. Two nuts jammed together. A little slop. What kind of contraption do we have here? Well, let's go hook it up to some air. I like those pushing connectors, I really do. Is this thing gonna go nutty? Okay, let's hook our airline up. Whoa! Whoa! I'd say there's a little bit too much pressure. It's a snapper. Take this thing and put it on your door with some clamps. Yeah, it might break the door, but it'd be a lot of fun. You could even put like something on there and shoot it up. Let's try that. Okay, let's put our Dracula friend on it. He's afraid. It'll be okay, Dracky. 5, 4, 3, 2, 1. Alright, let's send this friend too. I'll put him right on the end. See ya. Okay, I admit it, the door knocker's a little violent, but hey, it's all good fun. That'd scare the crap out of somebody if you're walking by and that thing clangs. It's barbaric. Right now I've got it going down soft, but I need the opposite of that, right? Mm-hmm. I don't know, it's loud and it's giving me a headache, so I'm gonna have to stop now. I think really, between the power of the cylinder or the motor or whatever you have, the most important part is the linkage. Because if your linkage is correct, your rig's gonna work. And there's kind of an art just to the linkages, really. Knowing where to put the pivot points and the points that have to lift and where it has to bend. But once you figure that out, you know, it's not that big a deal to make stuff like this. It's kind of fun. Now I know I've been skipping over the control part, like the microprocessors and that sort of thing, but that's a subject for another video. So if you want to see that, let me know in the comments. Maybe I'll scrounge some motor controllers up, or we could build something on the Arduino. Thanks for watching. Have yourself a happy Halloween and safe.